Alright, so in this video I'm going to show you several examples of different functions that we're going to be studying throughout the year, just to give you a little bit of an indication of how to find domain. Okay, and all domain is it's the set of x values that can be put into a function. So what are the possible inputs of that function? Okay, and that may not make sense to you at first, but really there are certain few rules that you should know about. You cannot divide by zero, you cannot take square roots of negative numbers, and you cannot take what we refer to as a logarithm of a negative or the value of zero. Okay, and so those three rules, dividing by zero, square roots of negatives, they are very, very important. Okay, so I'm just going to go ahead and get started. Alright, so the domain of this function. What x values can you actually plug in? So if you look right here, you should be able to see that here's your function graphed. And I want you to notice that back here in this entire section, okay, you don't have anything graphed. That's because it's not part of the domain. There's no values that you can plug in back here. It actually starts with this x value, which is at 3. Now if you look at your graph, it will continue to go in this direction, and because that arrow, it indicates it goes on forever. So that means it's going to go from 3 until infinity, and we write that just like this. Alright, your x-intercepts. That means where does it touch the x-axis? Now, you're just going to have to believe me on this one. This thing will increase for a really long time, forever and ever, and will eventually touch it. And it touches it at the point 840. And I just happen to know that because I know what the function is. Okay? But, another example. Okay, again, there's nothing back here. This function doesn't even start until this point. And this point is at the x value, -3. Alright, and it continues to go to the right for forever, hitting every single x value in its way. So that would mean that our domain is -3 to infinity. Alright, and we just write it like that. Okay, -3 to infinity. Okay, your x-intercepts. Where is it going to touch this x-axis? Well, the answer is never. Okay, because it's increasing, it's not decreasing, so it's never going to go down and touch that. And it is possible to not have an x-intercept. Alright, so, example 3. Okay, more of the stuff that you've actually seen. Okay, these are polynomial functions, and this one happens to be a positive even. But, I want you to notice what's important here. Okay, this arrow indicates that not only is it going up, but it's going left forever. And what's going to happen is, okay, I'm hitting all of these x values, it's bouncing up, curving, and then it's going to keep hitting all these x values and keep going not only up, but also to the right forever. That means it hits every single x value in the world, which would mean we can write it a few different ways, but I like to just go ahead and write this, all real numbers. Okay, it's easy, it's quick. Or you can write -infinity to +infinity. Alright, your x-intercepts on this one pretty easy. It touches the x-axis at -2 and +2. So our x-intercepts, -2, 0, and 2, 0. Alright, so a few more examples. Alright, again, domain. Which values can you put into the function? So this arrow right here indicates it's going to go left forever. Okay, I follow this thing. It's a continuous line. It doesn't skip over any values. And it goes, this arrow indicates to the right forever. So again, that same exact answer. It has a domain of all real numbers. Or you can write -infinity to +infinity. Alright, your x-intercepts. That would be at -2, 0. Okay, 0, 0, and 4, 0. Alright, So here's another one. Okay, again, this arrow on the left. Okay, and then, okay, it doesn't skip over anything. It actually hits all of these values and then continues on to the right forever. So domain, you're looking left to right. Okay, so again, one more time. Your domain, all real numbers. We like to say negative infinity to positive infinity. Okay, your x-intercepts. Looks like that's at negative 0.50 and 0, 0. Okay? But the idea, it's going to hit everything in the world because it continues forever, left and right. Okay? You may be tempted to say the same thing about this one. But this, if you notice, has this open circle here. Okay? At negative 4. And we call that a hole. So that's not actually going to be one of the values in our domain. It skips over that value. Then, if you notice, what it does here is it skips over this value. We call it a vertical asymptote. It's also not in our domain. So you would say that this thing has a domain of all real numbers, but, okay, those two values, negative 4 and 7. Alright, your x-intercept should be pretty easy on this one. It's right there where it touches the x-axis, okay, and it's at negative 3. Alright? Okay, and this is a rational function that we've been studying. Okay, and one more rational function just for our last example. Okay, if you notice, this thing will extend forever in the left direction, and then it shoots upwards right here, about where the y-axis is. Okay, then it continues here, and then our third piece here. Okay, so to find out our domain, if you notice you have a couple breaks in your graph. Okay, those breaks seem to be happening right here at 0 and at positive 3. So when you talk about your domain, that would mean that you've hit all of the real numbers, any real number, but 0 and negative 3. Or actually, I'm sorry, positive 3. Okay, your x-intercepts, it doesn't actually touch the x-axis, so it has none. Alright, so last minute, if you're finding domain, it's your x values look left to right.